Many people confuse the z-statistic and the t-statistic, yet this exact choice determines whether your test is correct or completely off. In this video, we clarify when do you use z, when do you use t, and why this has nothing to do with complicated mathematics, but with one single, simple principle. Both the z-statistic and the t-statistic measure or test the same thing. How far is our sample from the expected value, measured in standard deviations? Both follow the pattern. Test statistic equals observations minus expectation divided by the standard error. Or in statistical notation, z equals sample mean minus expected value divided by sigma, meaning the known population standard deviation divided by the square root of n, the sample size, for the z-test. And t equals sample mean minus expected value divided by s, which represents the estimated standard deviation, divided by the square root of n. Now to the decisive difference that determines which statistic or which test you should use. Z-statistic. You use the z-statistic when the true standard deviation of the population is known. That sounds trivial, but in reality it almost never happens. In textbooks or in very large, stable data sets, it can occur. But as soon as we work with real samples, we usually do not know this value. And this is exactly where the t-statistic comes in. T-statistic. You use the t-statistic when the standard deviation has to be estimated, meaning it must be calculated from the sample itself. This is the normal case in practice. Visually, the two statistics differ as follows. While the z-distribution is a fixed, narrow, normal distribution, the t-distribution has wider tails. This means extreme values are more likely under a t-distribution. The reason is intuitive. When we only estimate the spread, we are less certain, and that uncertainty has to go somewhere. It ends up in the fat tails of the t-distribution. The smaller the sample, the stronger this effect, and the larger the sample becomes, the more the t-distribution approaches the normal distribution until they are practically identical. So much for the theory, but let's look at a simple example that shows why and when each statistic is used. Imagine you want to test whether a coin is fair. You flip it 20 times and get 14 heads. You do not know the true variance of the population. You only have your 20 observations. So you must estimate the spread, and that is exactly why you use the t-statistic. But if you had 10 billion flips, your estimate would be so stable that the t-distribution would look almost perfectly like a normal distribution. In that case, it wouldn't matter whether you use z or t, but the t-statistic would still be the correct one. Finally, here is the rule of thumb that is correct in 95% of all cases. If you do not know the population standard deviation, always use the t-statistic. From a sample size of about n greater than 30, z and t are almost identical, but t remains the correct choice. I hope this video helped you understand the topic better. Thank you, and see you next time.